Well, hi, everybody. It's February 27th, 2021. The end of the month is rolling around, and we are continuing our journey into technology from every possible angle that there is, because it really has a lot of angles. And tonight we're going to work our way into some of the capacities and capabilities of things like the smartphone. And but we're going to work our way into that, a little bit of overview. Certain organizations are doing some tremendous development and refinement of the capability of that innocuous little device that practically everybody in the world is carrying with them. So, and I guess before we get too much further into it, we will just put out our community guidelines disclaimer before we get started on the content of our discussion tonight. And the points of view and purpose of this video is not to incite fear or violence or harass or bully in any way at all, but rather to share opinions and thoughts with other like-minded individuals curious about the subject, to encourage conversation and awareness. The opinions expressed here on this stream belong solely to the persons espousing them and are not a representation of the channel Cyberhuman Frontiers. None of our videos claim to give medical, legal, political, or financial advice. This is for entertainment purposes only. This video and our YouTube channel may in general contain certain copyrighted works that were not specifically authorized, but which we believe in good faith are protected by federal law and the Fair Use Doctrine for one or more of the reasons noted above in the Copyright Act of 1976. I am going to get right into it and check in with TMC at the same time. TMC, I'm getting ready to put up a share of those diagrams. And how are you tonight?
I'm good. I'm really interested in this particular topic, so I'm
me too.
Curious to see where it goes.
Huge. It's absolutely huge. So all right. So here, so I said we get into it, so a little bit by way of overview, which is just working our way towards it. So take a look at this stuff. We've got here in the upper left, we have a computer server. That's it's got a bank of processors in it and a whole lot of throughput. So people, hook up to the internet and it goes through into one of these things in the back end, and the traffic gets routed. It gets its domain names matched up. It gets sent and matched up and connected with other remote computers through one of these things, as well as hosting websites and these things as well. Next to that, we have a smartphone. And some of the people out there listening to this show might actually be more fluent with computers and terminology than I am, and that's good. Join the discussion, and if we leave anything out, please contribute. Please, you're part of it as well. We're glad to have everybody with us. So we got a laptop here. We have a display unit. We have what is your modern internet-enabled refrigerator. So there's a little ice maker, and this thing's going to, at some point in the future, and I've already seen them, as a matter of fact, have a big LCD display on this door of the refrigerator. So I've seen them where they got the ice maker here, and then they have a LCD display over here. Good size, mounted in portrait mode rather than landscape. And then further down here, we have a camera. Old school kind of cameras are, there's going to be TMC is going to get into a whole lot more about cameras in the future. I mean, what this is not a particularly advanced looking camera, and a microwave oven. So basically the idea is all of these devices will have connectivity. And then we go a little bit further. So that's, those are the objects in your home or in your office. And with the exception of this little device right here, all of them were, just in the space. those glasses were on body, and this item would be a wearable, and can show you what some of the capabilities of those things might be. And here we have an imaging transceiver, which is sending out, I'm going to guess that this is microwave radar, sending it out to create an image of the room by looking at what bounces back. And so notice that's coming out of a very small radiating element on that display monitor. So it's, doesn't take up a whole lot of space. What do you do with all this stuff? Well, it all gets connected. We have a couple of transceivers. We have a system connected to computers someplace. We have an imaging device on this monitor. The man is looking at that display monitor, but it's looking at him too. And it's doing it invisibly. So, it's knowing where he is. It's perhaps being able to use this to maybe interpret some of his gestures if he's doing an interactive presentation of some sort. But it can probably do a whole lot more. And we'll get into some of that stuff. And what else we got here? So now we have a wearable. And some of these wearables will actually beam electromagnetic energy or other forms of radiated input into the tissue underneath the device in the wrist. And I'm not saying that this one couldn't, but in this particular exemplification of a device, what it's doing is it's scanning the ligaments and tendons in that hand. It's probably interpreting what finger movements might be, as well as perhaps picking up some other physiological data. So they don't always just, those wearable Apple Watch type jobbies, they don't always image directly in, they also can image around. And that's what's being shown right there. And that pretty well, we get the same picture again there. That pretty well, remote biometric manager. That would be something noteworthy there. We have a processor, storage, we have some applications, and a biometric manager. So that would be a little takeaway from that. And, they're working on all this stuff. They're working on it. We'll show you. I mean, this is an actual patent. So this
is a patent from Google, as a matter of fact.
It is. It is a matter of fact. Yep. I'll zip right on page 9, zip right up to the very top of it and show you. Radar-based biometric recognition. The applicant is Google Incorporated. There you go, right there.
This ties into their Google Soli platform. So the Google Pixel phone
works
which
together
is just
with
one. There will be other phones, other manufacturers, other models that will have this technology. And what it is it's a no contact method to interact with your phone. That's how it's sold to you. You can swipe just by moving your hand. You don't have to actually touch the screen.
Yeah.
You're able to interact with your environment because of the radar fields that are emitted. That's what they're really showing you here in this particular picture.
Yep.
And they're able to understand, for example, that this guy is actually not watching TV. They can tell by the orientation of the head.
The hands.
They also discuss interconnectivity, not necessarily in this patent. There's other patents that are by Google as well, but your devices set up connections with the other nearby devices. So if you have a phone and a tablet and a watch and a TV and an alarm system and connected refrigerator, and they all talk to each other and they all can understand the environment better as a result of the communications that they have amongst themselves, whether you really set them up or not.
Exactly. It's pretty amazing stuff. Now, this is on the private, commercial, and consumer side of things, but we have more. And I want to I would like to give a little bit of background information. This is something that's slightly unrelated, but it's using the same type of technology. And if we were to, let me get to this. Okay. So these guys, at the Echodyne company have created a radar imaging array that is small and efficient. And so if we keep in mind what some of the developments are, and then we try to apply something at smaller scale to human interface, that's kind of what I want to happen as I breeze through this very quickly. So anyway, they're talking about a radar system that can detect obstacles in aircraft, maybe hundreds of meters away, but still be small enough and light enough that it could be put onto a small little aircraft. And drones are very, very small aircraft. And there's the array right there. And I'll show you this to show you the scale. This is that radar imaging array. And the scale of that kind of looks like, there it is. No, not that one. This right here. So that's how big it is. There's your smartphone, and that's the size of that. So the significant part about this is the technology that is in this white device, which is this thing right here. So let me just read this. We won't get too deep into the technical side of things, but here's the deal. Phased array radars use a grid of antennas that, by emitting radio waves in precisely defined patterns, can steer the beam in a desired direction. So this is an array of tiny, tiny, tiny little antennas. And by precisely this is things that we've talked about in previous shows, where when you have waves coming out of one of these little radiators and then waves coming out of an adjacent one, they set up an alignment pattern, more properly referred to as an interference pattern, between those outputs. And if it's controlled precisely enough, then it can target a specific point out in, the space distant from this device and pick up data from it and know what it is, where it is, whether it's moving, what type of, if it's a human, what type of tissue it is, what type of object it is, all of the above, all that stuff. I want to
add one thing. You showed a picture of a drone, but this is the same
technology,
or near the same form factor as what you'd find in an automated autonomous vehicle in a car. And I have some visual diagrams.
Oh yeah,
you want me to share?
Oh gosh, yeah. Let's do it. Yep. Get some motion pictures here.
Yeah, if you want to look at this stuff on your own, you go to humaninternet.org, go to the media section, and when you go to the media section, you'll see radar and 5G. And I want to show you here what he's talking about, what Indy was talking about, where with all of those different antenna elements, they can time when those antenna elements actually emit energy or fire. Yep. And they can steer directed energy around, radar beams around, and start mapping the environment and understanding very intricate details about what's going on. And this is how automated vehicles work. This is how drones work. And this is how imaging technologies work.
So, and just as an aside, it's probably well known to people that we've got cars that can park themselves now. And that car is able to know exactly what the difference between the curb and the pavement is, and it knows where it is and all that. So yeah, look at that. Look at what it's doing. Look how far it's looking ahead. This technology is amazing.
It's already deployed.
Yeah, it's out there. Look what it's doing. Is that cooler than cool or what? High speed?
I think one car, okay, it looks cool with one car. When every car is doing this, you're sending directed energy beams out from many different places simultaneously, and that's kind of, I have concerns about that personally. Here's another one.
It's a whole lot of EM out there, and it's not doing anything that our cells are going to particularly like. Maybe we can withstand it, but it certainly isn't anything naturally occurring.
See that? There's your heart rate signature extraction. It understood it was a biological life form.
Did you see that?
Yeah, let's go back and watch this again. I want to walk through this, Indy.
Whoa.
So this thing is imaging, and it's able to understand and map that car. It sees it as a car. This beam steering, beam forming operation doing the same thing, and it's able to basically do it to a 90 degrees. And there's your biometric identifier of a human, and there's simultaneous mapping, different frequencies, etc., through visually obstructed. And here's bouncing energy off of a wall to be able to see a motorcycle driving by. I'm going to show that again.
Wow. Wow. I never saw this before.
So it's shooting energy off the wall. It bounces it off like it's a pinball, and it's able to image around corners.
Yep. Freeze. So, can you freeze that right there? It's going to be hard to freeze it right on that, but okay, right there. Yeah. Okay. So it obviously, and anybody who's, played pool and knowing how you bounce balls off the boundaries, that's what it's doing. And it is able to see around a corner that the driver would have no hope of being able to see that motorcycle speeding through the intersection.
Mm-hmm.
Whoa.
Keep in mind, this is focused, co-limited, or coherent electromagnetic waves that are being emitted out of a vehicle, bounced off of reflective objects in the environment, and it's literally shooting or directing energy, focused, co-limited energy out into the environment. So you can see here that it's crossed over a crosswalk or a sidewalk. It's bounced off a wall or a window. Don't know if anybody's necessarily behind that window, how much passes through, how much is reflected off, because there's loss that's associated when you have a reflection or a pass through or absorption. And then you have the actual motorcycle rider that's being tagged with this directed energy at however many pulses per second. It could be pulsed in the nanoseconds.
Oh, sure. Nanoseconds.
Or the microseconds or the milliseconds. Pulses hitting this guy as he's driving, as he's not protected at all. And here it is crossing over a crosswalk again, or a sidewalk, and then across a crosswalk. So if this was a busy traffic corner, they don't show you people here. This directed energy,
it's fast. It would be able to track and image all the people.
It would be this directed energy. Yes, you're right. This directed energy would be able to identify a lot of moving targets at the same time. Yes. In order to do that, it actually has to make contact. The directed electromagnetic energy has to make contact with all of those objects. Yep.
But as you can see, the way it worked, it scans. It scans the whole field, and it does it very, very. I'm sure that it does it much faster than this illustration, than this video shows. Yeah. You guys out in the chat, I mean, this stuff, the advanced technology that we're seeing here blows me away. And this is in the consumer space right now.
That's right.
So if you consider that this technology can just be scaled down a little bit and built into a phone, and if you consider that anything that the military has designed is perhaps 5, maybe more years ahead of anything that we ever get to see, you can fill in the blanks from there.
What we're watching here is what was in the patent that you were describing.
Right.
That radar pattern that shows it as a cube or a fan or a cylinder, a 3-dimensional radar field, but it's pulsing that field so that it understands when changes are made. It's able to reorient the field itself to create 3-dimensional orientations, even 4-dimensional, where you're able to starting to understand time. So as these things move around, as these pulses occur, the phased array is able to take and move and shift the beams. And so we're getting what you're saying is true about the consumer space, and then getting it into a form factor like a phone. What I'm telling you is it's done. Google Pixel phones can do stuff like this. It may not be as detailed because of the form factor and cost, but that's simply a matter of time. You can look up other companies, Vyar and Natira, both are Israeli-based companies, and they're building chips that have 70 plus antenna elements on them that do the same thing. They're able to understand and do things like this. Beam steering. This is what beam steering is.
The question that I'd have for everybody participating with us is, when you go out to get your next upgrade phone, is it apparent to you that when you take that thing home and you lay it on the table in front of you, that it's not just doing recognition of the key punches that you have on the virtual keypad on the LCD display. It's scanning the area. That's how it does face recognition to let you into your phone. So when it's sitting on the table, it can be scanning the entire room and picking up all sorts of data about who and what is in that room. Same technology, and it like you by logic, you would know that if it's going to be able to scan your face when you try to get into the phone, why would the device want to stop scanning after it has recognized and allowed you access to your phone? Why wouldn't it just keep running? It's there. It can, it can keep collecting information, perhaps, theoretically for your convenience, right? For it to be attentive to you, but it's just not apparent. So the stuff really, it gives me a little bit of the heebie-jeebies, and it impresses the crap out of me at the same time. Really does.
Here's the other one. We'll stop after this one. This one's pretty intense.
Okay.
Just does some really cool stuff. Radar with 3D vision. Look at this thing. Multiple tracking, scanning.
Of course.
As fast as you can possibly, and you can see over on the right, it's imaging everything in real time while the vehicle's at speed, 50 miles an hour, whatever.
Yep. It's scanning the Jersey barrier on the side of the highway too. Yeah.
That's what it's reading there. Yeah, that's right. And you've got this super fast red sweeping beam. Here comes this accident. Watch this thing. It's literally shooting directed energy. So this will happen if you don't have radar, right? Look at this thing. It's shooting this is directed energy systems. These are directed energy systems, and it sees in between the two trucks right there, and it's able to track that vehicle. Just
wow.
Yeah. So,
did you see that?
Is this stuff?
Oh boy.
What frequencies are they using? Are these going to pass through vehicles, or do they pass through metal? Do they pass through windows? What about pedestrians on the side of the road? What if you're, what about the people that are in the buildings shopping or whatever?
That all goes back into that territory of that's in the we don't know zone, right? That's we're putting our trust in whoever it is that designs this stuff. We know these engineers are going to build it so that it works, but we don't know that they're building it in such a way that it took into account, biological injury to humans or anything else.
Right.
I mean, so maybe you'd be okay. There you are, you're crossing in front of a car that's beaming this stuff out. And, maybe you're a big, strong human, but what if you're carrying your sick little chihuahua to the vet across the street and it's already ill and it gets beamed by some of this stuff. And then before you get to the vet, the chihuahua has passed away because it was already weakened. There's so many things that just, I don't know.
The argument there is there's no reason to
save the chihuahua.
Have no reason to have any concern over any electromagnetic energy in the environment so long as it isn't transmitted.
What do you mean?
As it isn't transmitted above the FCC regulations. And what they're not telling people is that there is a cumulative effect, number one. Number two, there is a wave interference effect that's either possible from the same antenna array,
right. Exactly.
or from multiple antennas.
I'll simplify
that are not mounted together, that are not on the same device, then can emit energy into the environment, and those waves all interact. So that's why I was saying earlier, it looks great with one car, but what happens when 50% of the cars that you see on the road have radar technology that's always on? It's going to create an entirely new invisible environment that we're all going to be exposed to, and there are cumulative effects on multiple levels.
I'll say this. The simple answer, they don't care. They really don't care. I know they don't care.
Interested in the money.
They just don't care. If you consider how hard it would be to try to figure out to come out with a FCC maximum radiation limitation standard, then they have to decide, well, that's based on how many cars are on the road. What if there's a whole bunch of cars and there's a traffic jam and none of them are really moving, so they're all bunched up? They may be moving really slowly, and a whole lot of these vehicles have got their beams all going, And they're all, since the cars are so close together, they're within 50 feet of pedestrians on all sides, just a crowded area. The amount of electromagnetics in that area would be way over. I mean, it would just be way over what you'd experience in a non-crowded street with just one car.
Right.
They present this for approval based on an ideal case. They're going to show
an antenna transmitter.
Yeah, right. They're going to show one, maybe two cars, maybe a pedestrian 50 feet away. But what about when you get
in order for a manufacturer to have approval, they have to show qualifying test data that their product transmits within the required field parameters. So they don't go above the specific absorption rate, and so they don't transmit an electric field or a magnetic field above what the FCC says is healthy. And some of those are contingent or based upon what frequencies are being used. But when they're submitting these test results, it's only for the device, the manufactured device. It has nothing to do with what's actually in the environment.
Has anybody
effect? And so when we look at this idea of AI and we look at this idea of cloud or cognitive radio, who do you want to have control over your telecommunications networks? And it's really, really simple. When you have 50% of your cars being able to use phased array radar, when you have drones delivering packages from Goliath corporations like Amazon, who also have radar technology so that they can operate efficiently and quote unquote safely. And all of this stuff ties into 5G, the 5G network. And then you have the 5G antennas that are out every approximately 800 to 1,200 feet, and multiple antennas, that antenna arrays that are about the size of a pizza box on a metropolitan corner. You'll have 4, 5, 6, 8 of them, so that you have coverage everywhere. It's a lot of environmental exposure, electromagnetic exposure in the environment. And when you look at the requirements for rating this stuff for it to be quote unquote legal or within compliance, it's strictly manufacturer specifications. It has nothing to do with what software can do once all of these radiating antenna elements are all connected together and put out into the environment. At that point, software has more control.
Dude, those things could. I'm not saying that it would be done, and this show is for entertainment purposes only. This is not to incite fear. This is just for intellectual discussion and conjecture. But if, under software control, a large number of those radiating elements were focused, and you know that they can be focused to provide a directed energy beam at a target. What if many of them were focused on one point? Let's say one body, one human. They're all there. It's just a matter of what the software tells them to steer toward.
You mean like this? Like an electromagnetic weapon courtesy of the U.S. Navy that shows multiple antennas focusing on a single point?
Yes.
You mean like this?
Just like that.
An electromagnetic weapon that includes semi-randomly arranged antenna elements and a central weapons computer. You mean like a cloud-connected 5G network, or let's say a fleet of Teslas? And I'm not saying Tesla. I'm saying a fleet of Teslas that maybe something like Amazon would want to contract a Tesla truck or a mid-sized industrial-sized automated vehicle, where you have a fleet of them, or you have multiple connected devices in your home. Tablet, cell phone, smartwatch, Wi-Fi router, television, refrigerator, thermostat, alarm system, and on and on and on, all of which have antennas that you could then select each one of those antennas and focus the energy to a particular point. They're coordinated. The antennas are coordinated to function as an active phased array capable of finding and executing a resonant mode of a target. So you would be able to know what resonant frequencies you needed to emit, be able to emit the radiation into the environment, use wave interference to generate the appropriate fields that you wanted, magnetic fields or electric fields at the right resonant frequencies. all
target.
controlled with the central weapons computer. And Google has patents that discuss being able to manage connected devices in an Internet of Things environment.
Yeah, exactly. That's kind of what I'm thinking. And I carry it a little further. I'm saying that in the sidewalk of the future in an urban area where all of these devices are deployed, active, operational, I am under no conditions comfortable walking down that sidewalk, not being able to sense in any way. I mean, you can't feel this stuff until something's been cooked, all right? I'm under no conditions comfortable walking down that
more
sidewalk
sophisticated than that.
without wearing a complete metal jacket, all right? And then the reflected beam off me in my metal jacket is probably going to annihilate the person walking next to me that has no protection.
There's two things there. I like the analogy. Number one, they don't need to heat up your body to break your body. All they have to do is find the right resonant frequencies. You can look up ion cyclotron resonance or electron cyclotron resonance, and what it will show you is that at a very, 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 very low power with the right modulation, you can start controlling things like calcium, potassium, sodium, and chloride, which are all electrochemical necessary things in your body.
Electrolytes. Yep.
Right. Exactly right. Which regulate your nervous system. They regulate your brain. They are what keep you alive. And you can with ion cyclotron resonance or electron cyclotron resonance, you can begin to manipulate how those ions pass or don't pass through cell membranes. And now you're talking about disrupting the nervous system, disrupting the heart, disrupting the brain. And none of it necessarily means that your body temperature is being raised with the exposure to electromagnetic radiation. That's point number one. Point number two, you're talking about wearing a Faraday cage around your nuts and your head and your whole body, right?
Whole body.
Right. So this patent right here is an electromagnetic patent that talks about concentrating electromagnetic energy at a remotely located object. So if they make clothing that way, and they do, they make EMF clothing that is reflective or absorbs. If you were to walk around in that hypothetical scenario, they would use you as a reflector. And so what this talks about, and I raise the point for this reason, there's metal everywhere in the environment. Cars.
Yeah.
The hood of a car, a street sign, stoplight, manhole lid, anything, a wall, some type of a metallic structure. What this patent talks about is being able to concentrate radio frequency energy, RF energy, on an object located nearby, a reflector. So you have a target that you want to concentrate electromagnetic energy on. Nearby, there is something that is a reflector of electromagnetic energy.
It'll calculate the bounce off because it will have already imaged and gotten a reflection right straight back from it.
That's right. It maps the environment. It understands what's reflective. It understands how it reflects. And it also is able to determine what the resonant frequency is of the reflector so you can concentrate the energy. You can change the frequency and change the modulation so that when the electromagnetic energy is applied to the reflector, it creates a resonance and actually amplifies the signal.
Yep.
And then it's bounced off at the right trajectory. It's bounced off with the amplified signal to your target.
Yep.
That's what this patent talks about. And that, FCC didn't talk about that at all. And if you can amplify a signal with wave coherence or by utilizing resonance,
well, question. Hang on. Question out in the chat is what will calculate the bounce off? Well, what it'll do is it has a known timing signature that it's looking for any particular distance. So it sends out, and this is just one, but
it's called time of flight, angle of departure, and angle of arrival.
Right. The device knows the speed of light, and the speed of light is the same speed that the microwaves travel at. So based on what the time duration is from when it's sent out a pulse to when it receives an echo back, that tells us a position of, it tells a position of something. So if you remember that animation that TMC showed at the beginning, the device, the radiating device, is sending out a sweep, and it's looking at all of the received signal coming back from that sweep, and it'll be all different. But what it does is it constructs a picture of the objects and all of the things that reflect it back. And so that's the simple version of it. But TMC carried it further. He then went and said the thing is also going to be able to sense the resonant frequency, or the type of material that's bouncing it back. And so that would differentiate between a metal object or something fleshy and soft like a human, or the beloved Chihuahua that's on its way to the vet.
And we also have reflective properties. That's what they're selling with millimeter wave technology, is that
Right.
it'll bounce off of us. And
Yep.
so we have, your body has unique resonant characteristics. You have
Yep.
a whole body resonance, you have an arm resonance, your head has a resonance, your organs have a resonance.
Bone versus soft tissue, all
That's
that.
right. And so based on what frequencies are used and how they're modulated, you can start exciting particular parts of the body, or you can start exciting or resonating particular things in the environment. And it's all invisible. It's all outside of the light spectrum. So you're not necessarily going to see it.
So there's two parts of this going on. One is just the imaging part, in which it maps everything out. Then once it has mapped things out, there are other patents that we've talked about. It won't be within the scope of this show, where then it does that resonant bit that you were talking about, where it's then going to target the altering the permeability of a cell membrane for sodium or chloride, for example, or calcium. So that's the next step. Once it has identified the different types of structures out there, then there's the next step, which is sending energy out for the purpose of doing that resonating. But the thing that really gets to me is there's just no way that it's such a complex environment with living creatures in it. There is just no way that they would have promoted or presented this in such a way that it was a really complicated environment. Let me give you an example. Let's say 50% of the cars have these imaging, and it's cars only, have these imaging devices on them, these radiating electromagnetic directed energy scanners, let's call it. Have you ever been to, a big public event or a concert, and then it gets over, and then there are a line 4 cars wide and about 100 cars deep of cars waiting to get out of the area wherever this arena was. And then there are throngs, myriads of people that the cars have to stop for to let them go across the street to get to wherever they parked their cars. So you got 100 cars all beaming energy, scanning their environment, and you got hundreds of people walking in front of those hundreds of cars, all getting imaged, beamed, and irradiated by this. Now, I can guarantee you that when this is considered by the FCC, that is not an example of what they would say, well, gee, yeah, there's a lot of electromagnetic radiation and we're irradiating 100 people at a pop as they go across the crosswalk. No. So they don't care. But this show is for entertainment purposes only.
The regulations with the FCC haven't changed basically at all. There have been a few modifications, but not anything significant as it relates to the health implications.
The advancement of the technology has vastly outpaced the updating and regulation coming out of the FCC. And
1996.
96 versus 021. So no, not electrocution. Rocky Mountain Rio. No, it wouldn't be electrocution. It wouldn't be visible burning. That would be something that would bring attention to the whole situation, and it would result in a whole lot of bad press for the companies that are making and deploying these devices. No, it's much more subtle and invisible than that.
I think it depends. I gotta add to your answer. It depends on what your definition of electrocution is. If you're going to use the classic imagery of electrocution, where you have involuntary convulsions and whatnot, then I would agree. But
yeah,
if
the classic is you get zapped, your hair stands up, your eyes bug out, and
electrocution could very well, it very well is possible. If you are in a concentrated electromagnetic field, it's generating an electrical charge in your body, particularly a magnetic field. But an electromagnetic field has both.
It depends on the frequencies. I hearken back to Nikola Tesla, who was a really smart guy, and that's an understatement. And he demonstrated that certain frequencies of alternating current need not be harmful to the human body, but others can be. And what I would suggest here is that there is no connection between the companies having an interest in people's safety versus getting the functionality that they want, that they're looking for. So it could be that you could be in an electromagnetic environment and it wouldn't be harmful, but that ain't what's going on here. I know it isn't. I can just smell it.
I'll say this about that. We're building platform. The technology is good enough today that we're now building platforms that offer both. We're building platforms that are going to allow software and AI to destroy biologic life or to enhance, reinforce, and repair biologic life. The platforms are the same. The manner in which the platforms are used is really the issue of the day.
Exactly.
The technology is evolving. How it's used has everything to do with our perception of the technology. And that's where cloud radio antenna networks, CRANs, or RATs, radio antenna. There's RATs and there's RANs. They're basically the same thing. The RATs is escaping me. Radio antenna transmitter, excuse me. What that really means is that the cloud, what we understand as the cloud, manages the transmission and the reception of electromagnetic energy from antenna elements, cloud-based network management in a wireless environment, which means that AI has to be involved because of the complexity. To manage everybody's individual cell phone connection, to manage vehicle traffic, to manage drones flying around.
And to manage the operation of all of those detection and monitoring devices too, right. All that.
So all of that is automated to a great extent. And so the cyber component of modern telecommunications infrastructure is huge. It's huge. Whoever has cyber dominance really has control over the entire society, because telecommunications are a critical foundational piece of our society, and even more so going forward as we transition into the proverbial fourth industrial revolution. Telecommunications will govern transportation. Telecommunications will govern manufacturing. Telecommunications will govern food production.
Yep.
It will all be connected, and most of it's going to be wireless, which means it needs antennas, which means that we're putting radiating elements out into our environment that are all connected together in the proverbial cloud, and the cloud is the central computer.
And why would they do things wirelessly? Because that allows scaling up to a tremendous degree. Here's what's cheap, going on.
Mobile. You're not tethered, and it's incredibly cheap.
Right. The transmitters and the transceivers. Transceiver is a transmitter combined with a receiver. They're getting smaller and smaller and more efficient. And those are so much more easy to deploy than anything that has to have a wire connected to it. And I see the comment, CPAP now has Wi-Fi. I'm not surprised. And paying attention to the chat and the questions. The big difference between this electromagnetic radiation that we're speaking about and the static electric spark shock that you'd get from walking across a carpet, that's a whole different thing. This is a completely different animal than that. So there is a lot going on, but the amount of it that's getting out there, because of what you just said, TMC, the transmitters are getting cheaper and cheaper and so small. It is, I mean, on $1,000 refrigerator, the cost of building the transceiver, the Wi-Fi connection into that refrigerator is probably a couple of bucks. Literally, that's all it is. It might even be less than that. So the deployment is quite scalable. And the other half of it that they need in order to be able to connect with all these things is the advancement of 5G and, more towers, more sending and receiving units out there in the public space, on your street corner, on your lamppost, on your telephone pole, or at every street corner, wherever, so that's the other half of it. And then there's the connectivity part, which is where all this data is getting channeled as it goes through those pickup nodes, which would be those 5Gs and those other things that you see pop up, and the central computers where all that information is being fed back to, or sent out from, to send out through that public node out on that street corner to your device or to your wearable. So it is absolutely mind-boggling.
Yeah. So
to me,
just to, I guess, round this out, this is a company, Vyar, and it's a Israeli-based company. They have, I had this recollection of this particular image they have on their website, and what you see here are antennas that are all on a chip, and what you see are 40 antennas on two sides of this piece of equipment. And the chip is, you don't see the whole chip. So when I said 70 plus, I'm not kidding. I mean, they'd be able to dress the outside, all four sides of this chip with antennas. And when you get something like that, you get a form factor that gives you something that'll fit in a tablet, something or a computer.
Oh, easily.
Mm-hmm. Even though that's not what this image is depicting. This image is depicting more or less the software component of it. And it says here they can understand physiological characteristics, your gait analysis, breathing monitoring, posture detection, sleep analysis. They can understand your behavior, activity levels, when you wake up, when you go to sleep, nocturnal roaming, when you go to the bathroom. All information can be displayed on either a single or a multi-room dashboard. They put this stuff in cars and they get high-resolution images of, I mean, this is a perfect example of an infant laying in one of the car seat things that you could take out of the car and put it in a stroller. And it's in its reclined position, imaged that way.
Right. Marketing
analytics, something that would look like a benign Wi-Fi router that's posted on the ceiling, right? That's able to track everything. If they can RFID everything in the store, and they can track users walking around, shoppers walking around. They can track mobile devices. They can communicate with the mobile devices. They can communicate with anything else that the retailer wants to digitize. And
these things can come in all sizes and in all scales for imaging. So we had that one that I put up initially, which was on a drone that can image things accurately out, maybe a mile, maybe a half a mile anyway. Then we showed the car ones, which are scoping out, a good quarter of a mile ahead. But you can have smaller ones that they wouldn't be able to read the environment a quarter of a mile away, but they're much, much, much smaller, which is what you're talking about now. And if that is in a personal device that you're carrying with you, then the resolution of the precision of its imaging or its electromagnetic focusing and targeting will be extremely precise. Mm-hmm. Very precise, like down to a very small part of your body.
Yeah, it says in the Google patents for their
subcellular,
sub-millimeter.
Yeah, and there was another comment out here about millimeter waves. Yes, but it's not on your topic. But yes, a comment was out there that can millimeter waves burn skin. They could, if they wanted to
Yes.
heat the skin up enough to burn it, it could do it. Yes. That's not their goal. Their goal is not to actually give people visible burns.
72 on this particular chipset, 72 transceivers across ultra wideband. There's a standard for that. It's
which we covered. Remember, like about 6 episodes ago.
Gigahertz, something like that. Yeah. Well,
yep.
Here it is, right here. 3 to 12 gigahertz, and then this goes up to 81 gigahertz. So this is a flexible, scalable chipset that can transmit electromagnetics in a raw form between 3 and 81 gigahertz. And all you would need to add is something like a doubler, which is able to multiply the frequencies. They can actually take a baseband frequency, and they may actually use it in a chipset like this, where the frequency transmitter, if you will, the frequency generator is the term I'm looking for. It may not be able to generate up to 81 gigahertz. It might only generate up to like 40.
But a pair of them together can generate an interference pattern that will be at that frequency.
They can use a frequency generator, and there's a technology that basically allows it to multiply the frequency of the baseband. So they can double it or triple it, yep, or whatever, and create complex frequencies that are actually higher in frequency. And it's just a cheaper way to transmit the energy, just for manufacturing purposes.
Do you want to dive over briefly to the Darpa patent, the wash stuff, and if we do, I think that everybody could just keep in mind that everything that they refer to that's for military or defense purposes is all totally applicable to consumer application, or to have just your average regular Joe person be the target of it as well. Do you want to go there?
Will be soon. Yeah,
we could.
So this is a WASH program, and this is something that DARPA put out. 2017 is when they solicited or submitted their broad agency announcement, and it's warfighter analytics using smartphones for health.
So letting that sink in right there. So it's not some newfangled device. It's a smartphone.
It's a smartphone.
Yeah.
So it talks about a need to understand when a warfighter needs medical intervention, or if there's a change in the warfighter's readiness. Are they able to perform their assigned function? And if so, how effectively, how efficiently? And the goal of this program is to manage and understand what the level of readiness is for a warfighter. So you can translate that to what's your level of readiness to fill in the blank, go to work, perform your function at work. What's your level of readiness to drive your car? What's your level of readiness to raise your children?
So keep in mind, this is mainly a software technology, and what they're doing is they're leveraging off the fact that there are so many smartphones out there already. And so in one of the sentences right in what you got, bottom sentence, first paragraph, on 92% of adults in the United States own a cell phone, which could then be, once again, could be utilized for that leveraging. So right that
you should have just finished, yeah, brother. Used as a basis for continuous, that's real-time, 24/7, continuous passive health and readiness assessment.
There you go.
Now, this is physiologic and psychologic monitoring, potentially, of the entire population.
Or 92% of it, yeah.
And then comparing and contrasting whether or not an individual is within the assigned thresholds
of readiness.
Are you a good global city, or are you not a good global citizen? And the military is undergoing a 60-day stand down, if I'm not mistaken, rooting out extremist views and behaviors, identifying people that are considered extremists in the military.
That's right.
And so this program, Warfighter Analytics, everyone has a smartphone, 92%. right? So you can theoretically monitor.
I know the comment out in the chat. Yeah, they want Wash Program Warfighter really is going to use a smartphone for my health. Sure it is. Yeah, I see. I agree. I see it. Yep.
Well, health is a cute and fluffy way of saying that they're measuring medical-based information.
It's cushy. It's fluffy.
You wouldn't want to say that
soft.
this program is circumventing the HIPAA laws, would you? That doesn't sound as good.
No.
But that's really what it's doing. It's circumventing the HIPAA law. If it's able to take your blood pressure, monitor your heart rate, understand your stress levels, theoretically be able to understand your glucose levels in your blood, understand your emotional state when you deal with individuals, whether it be in your family or at work or out in public.
Or understand the change in all of those parameters when a certain subject is flashed onto the text screen of your phone.
And there is the psychological piece to be able to understand
that can be interpreted. Yep.
With that level of specificity means that the system, and I say that as proverbially, right, with Eric, with the system, the AI technocratic system knows you better than you know yourself.
Yep.
It's able to understand the most subtle changes. They even talk about being able to use the proximity sensor
to give credence by way of a distant parallel to know you better than you know yourself. Remember in the animation, the person's driving a car and there's a motorcycle coming from a side street. The car and the technology is able to interpret the environment better than the human can. So now extrapolate that to what TMC just said. It's to know you better than you know yourself. Are you fully aware right now of how many respirations you had this minute? Are you? Everybody can answer that question, yes or no. Was it 5? Was it 6? Guess what? The smart device will know, and it will know for every minute of every hour of every day if it wishes to.
Excellent analogy, Andy. That's perfect.
Yeah.
It knows how much your eyes dilate when you look at a blonde versus a brunette.
Yep. And are you aware of that? No. Mm-hmm. You're only vaguely aware that, something made you feel happy and something else may not have. It's got all of the specific parts of those parameters
and
that make up.
And the intensity of the parameters.
Good point. Yep.
Yeah, it's a critical piece. Nielsen neuroscience. We watched a Nielsen neuroscience video once upon a time. I think it was on the other show.
Yep.
And the head neuroscientist talked about not only being able to understand consumer sentiment, right, how you feel about something, but what the intensity of the feeling is.
Right. Yep.
And that it has a huge deal to do with the amount of weight or the amount of importance that experience or that stimuli, what it means to you, how it affects you.
Because then they can compare. They can experiment with slightly different media, and they can kind of dial in on what is the best, what's the one that causes the best reaction, whatever reaction they're looking for. I mean, ideally, it would be to sell people on whatever, watching their media or whatever it is. But they can dial it in by substitutions and then looking at the reactions. And all they need is a captive audience of people who just happen to have a device that is ubiquitously monitoring all this stuff.
So let's break this down. I was going to read the text in it, but the pictures here, I think, are going to allow us to generalize it pretty good. So when you're actively engaged in your phone, it's able to look at your eye movement, understand your voice. It's able to understand the device orientation. Is the device pointed out in front of you? And if so, are you heading in the north direction, the south direction, east, west? Gives you a GPS location.
Yep.
It understands or can see your finger images, gestures, and finger pressure. How hard are you pressing on the screen? How tightly are you gripping your phone? Grasping pattern, hand movement, application use patterns. How often you check your email? How often you check Twitter? How often do you check your text messages? It's able to understand your heart rhythm, facial recognition, full or partial. It can understand your gait, meaning how you walk, the speed at which you're moving, and the motion of your body. using smartphone sensors, and these are just a few of what's in there. There's upwards of 20 plus sensors in a cell phone: camera, pedometer, a light sensor. So that's easy. Light sensor would be the infrared or the ambient light, so your screen changes brightness.
Magnetometer, velocity sensor, temperature.
A magnemometer. They've got a Hall sensor, which is another type of a magnetic sensor. You have an accelerometer, a gyroscope, a microphone, a proximity sensor. These are huge. Proximity sensors are huge. The proximity sensor can be infrared. Proximity sensor can be an electric field. And proximity sensor can also be an ultrasound transmission and reflection, and it can also be an electromagnetic ping. So proximity sensor is a very generic way to classify a category or a group of sensors, which are either an electric field that's generated around the phone, front, back, left, right, all of it, an electromagnetic ping, an ultrasound ping, or an infrared laser that's pulsed out, and you have the camera or an infrared photoreceptor that's going to understand the reflection back, and it's able to map the room. It's able to understand distance, orientation, and material type. It can understand if it's in the pocket. It can understand if it's in your hand. It can understand if it's on a table. If it's on a table, is it a concrete table? Is it a wood table? Is it a plastic table? It's able to determine all of those things based on electrical characteristics, electrical properties, and reflective properties, light, sound, or other electromagnetic frequencies.
And it gets even a little bit better. It gets even a little bit better because they're with enough precision, and if they're proximal enough, they can do gas monitoring. It can determine how much CO2 is coming out, because that changes the density of the air differently from the infrared, just Indy. Plain. What's that?
It does it with the infrared.
Yes. Oh, yeah, I guess.
Light can measure the gaseous content of your breath. It absolutely can.
So there's that element as well. So
you can argue that it's done with the radar applications too, but I think you would have a lot of people saying no. Very, very interesting thing about carbon dioxide is that it resonates in the infrared part of the spectrum as opposed to oxygen or nitrogen. And that's why there is such a thing as a CO2 laser, because they put CO2 in the laser tube and it radiates in infrared. So that's a characteristic of carbon dioxide. So you're absolutely right. I just connected two dots in my mind. Very good. I learned something today. I didn't know that.
Yep.
The CO2 laser piece.
They're infrared. CO2 generates a coherent light in the infrared band. Yep.
So context of use. This is, again, the WASH program, warfighter assessment using a smartphone. Active use of the phone.
The deal is, at the very best, then what I'll say in no other term other than that it's highly invasive and very invisible technology to us, at the very best, what it could do is it could help us to communicate better with other people and to interface better with them, because the AI would know what our mood and then hence our outward projected demeanor might be ahead of time, and it could either enhance or sort of broker communications with other people. That's at the very best. But then there's the side of it that's potentially the very worst, which is all of the methods by which it can gain information that it has no business knowing about a person and use that to the advantage of somebody else.
Would you say in general that it could be assistive or disruptive?
Yeah.
Collecting the same information. And it goes back to how is the technology actually used?
Right. So I look at it, and it is absolutely stupendous technology. Just the stuff that we showed in the animations with cars is mind-blowingly advanced. But this takes it to, an exponential tenfold higher when we're talking about applying it to people and
this
everything.
That NASA would have had in the 60s.
Yeah.
To send astronauts out and to be able to understand at distance remotely with an astronaut out in space, having Houston, for all intents and purposes, understand medically as best they could what's going on with an astronaut who is all alone out there in space.
Yeah.
And the technology has gotten so good or cheap enough to manufacture on a mass scale that it's now deployed everywhere in something like a smartphone.
And when we talk about cost, we gotta just stop and consider cost and how it's come down so much. Let's say that you wanted to record any kind of a piece of media in 1981. It was a gigantic thing called a video cassette recorder that had these big tape cartridges that go in them, and you could record an hour at a time. Now, and the resolution was really poor. So you just take a look at the level of advancement now with any of a number of little devices, from a GoPro to a smartphone to the cameras on a drone. The resolution of pictures and the size of that camera is tiny. I got a laptop in front of me, and the camera on that laptop is no bigger than a pencil eraser, and the quality of image capture is quite remarkably good for a camera that small. And they're better than that now. So it's intense. And as far as recording at high resolution, whoa. I mean, it's light years, literally light years ahead of the other, the older stuff I just referred to. So this is technological advancement, and we're showing you the cutting edge of it. Well, what we know of the cutting edge of it that's in the public sphere. And you got to keep that in mind too. We're never going to see anything that's, a top secret advanced research project. Well, not right now anyway. But you
might see it, but nobody will believe you.
Right. That's right. This stuff is hard to believe. It kind of is, but it's there. These devices, these studies, this research, these applications, they have been done. A lot of these patents aren't even new. They're a couple of years old.
Yeah, I'm going to show you one in a minute here, but I want to just to round this out. This is some of the things, not all. This is just what they propose, not what they're actually going to come up with when they fund millions of dollars into this program. This is what your phone can figure out about you. It can understand excessive sweating, a shaking voice, hands that shake, muscle tension, facial tics, a racing heartbeat, a rise in your blood pressure, facial freezing, a change in how you walk, what they call a gait variance, decreased attention or decreased concentration.
How do they determine that one? How do they determine decreased concentration?
They can look at, if you're looking at your phone, they can study your eyes. They can study where your eyes are looking at on the screen, how long they're looking there for, whether you're rescanning the same information too much. Okay. They can understand how and what you're typing, how you're scrolling. Right. They would be able to understand if the thing was in your pocket, because it's a warfighter environment. So if the thing was, stowed away in a pouch or something, they'd be able to use something like a change in your walk and a change in your communication, if the microphone was available, right? And or what they would deem down here as an impulsive action, and through machine learning, be able to understand what your normal behavior patterns are, looking at a number of metrics, and then determining that there is some decreased attention or decreased concentration because there is a change in what the sensors are picking up that's a variation from what is normal. Right. So they can do it easily while you have a camera looking at you.
And that's the same way that they determine the diminished reasoning ability. Well, actually, a slightly different way. They'd put a prompt up on the. Let's say you had the device in front of you and you're interacting with it. Diminished reasoning ability. They'd put a prompt up there, and you might delay your response. You might be slow, or you might even give a wrong answer and have to do it again. That's right. And they'll extrapolate from that the level of reasoning ability.
Yep, I see a comment out there about could they notice your alpha beta waves?
If you're wearing a Bluetooth Beats by Dre set of earbuds, yes, they could definitely.
This program specifically talks about just the sensors on a phone, no peripherals. They just want what they can get out of a phone.
Okay.
And so they're not going to tell you, because to me, that's classified. If you were to tell people in a public announcement from DARPA
Phone reads
that
your
they're looking at
EEG.
having a cell phone monitor your brain waves using nothing else but a cell phone, they're not going to be okay with that. They just won't. Having said that, right, there are patents that literally talk about using electromagnetics to remotely monitor and alter brainwaves, and this is back in the 70s, where they're able to transmit two different frequencies into your brain and read the third frequency that is generated as a result of those two frequencies interacting with the electromagnetic characteristics or fields that are ongoing in your brain. They can then remove the two frequencies out of the third frequency that is the result of those two frequencies going into your brain. It makes a third frequency after it interacts with your brain. They can remove the original two and extract your brain waves. They can then use the extracted brainwave information and modulate electromagnetic energy and put it back into your brain and change your behavior. That's what this patent right here talks about. Apparatus and a method for remotely monitoring and altering brainwaves. And there's more. Again, this is on humaninternet.org. You can go look at this stuff. Communication system, including a brainwave analysis and or use of brain activity. And this talks about remote communication, covert remote communication. And this was back in 1998. And they talk in here about having something implanted. And there's one little sentence in this patent that indicates that you may or may not have to have an implant, and that a device nearby you would be enough. And it talks about sending your brainwaves up to a satellite and transmitting it back to the United States for covert communications if you're functioning in another country. Here's a Russian patent that talks about using Wi-Fi, Bluetooth, and cellular frequency signals to detect human microwave electromagnetic activity, brain activity from humans in the microwave range.
There it is.
What's that?
There it is.
Yeah. 1.5 to 5 gigahertz, which, and it literally talks about novel military it doesn't say specifically what the applications are, but it says that this technology provides an opportunity for, in the near upcoming future, major advantages for military applications, medical applications, and consumer applications. It talks about this in this patent. It mentions that 1.5 gig to 5 gig. Applications of this invention for both peaceful and military purposes can be created in the near future. And it's able to understand the analysis of microwave bioelectric activity of the brain under normal and pathological conditions for diagnosis of a number of functional and emotional states of the brain. For example, depression, aggression, emotional instability, mental disorders, mental diseases. Can be used for examination, for military medical, civilian medical, social, clinical, social, and labor. Keep in mind, this is written by Russians in their culture, their society. Can be used for neurological and neurosurgical practices, so they can remotely monitor what's going on in the brain while somebody's undergoing surgery. That would be very useful without having to put a bunch of attachments onto the body or onto the brain. If you still wanted to understand what's going on in the brain while you're performing surgery.
Yep.
Awesome. Can be used for military medicine and disaster medicine. And then there's another.
They could also probably use that to block transmission from pain receptors and need less of a chemical anesthetic too.
There's patents from Elizabeth Rauscher, who just passed away, unfortunately, a brilliant lady. She has multiple patents out that discuss using electromagnetics, one of which is to modulate pain and to regulate the heart using very, very low electromagnetic fields. Very, very low. And she has another one for enhancing, I think, biochemical signaling, something like that. I know I'm chopping that one up. And then another one to deal and treat osteoporosis, where they can actually help strengthen bones using electromagnetics.
Wow.
Yeah. Miss Rauscher was a super smart lady. I got
to write that name down. I got to do some reading.
Rauscher, I believe. Just
looking it up right now.
Awesome lady. Here's a patent. I think I didn't This one is for sensing and modulating of neuronal activities. This patent talks about being able to dump sleep hormone into your brain, where they can energize the VPLO center in the brain and cause the brain to go into the deep sleep state. And when that happens, the brain actually excretes a hormone, and you go to like you're done. And so this has been weaponized. China has weaponized this. There's a world patent from the World Patent Organization, and there's a Chinese patent for eliminating the fighting force. I'll show you in a minute. Right here, eliminating the fighting strength of an opposing combatant using an electromagnetic wave. So they took this medical patent for sleep disorders and for being able to remotely monitor, to be able to help somebody go to sleep, and to be able to understand their sleep cycle by looking at their heartbeat and the respiration using electromagnetic waves that, you don't have to have any contact, no contact. They took that and they weaponized it, and they made a system that is able to eliminate the fighting strength of an opposing combatant using electromagnetic waves. And in the patent images for this one, they literally talk about transmitting electromagnetic waves onto troops or like onto a pilot in an airplane, and it completely immobilizes them. When you go into a deep sleep, the brain and the body actually have a separation. And your muscles basically go into a type of a paralyzed state. And even if you're awake, your eyes don't work anymore. You see black, and it's as a weapon, it would be lethal as hell. I mean, if you're flying in an airplane and you don't have AI to pick up your slack, and you get this done to you,
shut you right down.
Yeah, you're gonna crash, dude. You're done.
Yep, that's right.
Same thing with a boat or troops. You could just put troops to sleep.
The thought that was crossing my mind somewhere is when you mentioned, well, you were reading and you said military applications versus civilian applications. And so when I think military, I think war, right?
Yeah.
And when I think civilian, I think, well, all of those things that we would like to think are that make life better, everything that we need to support civilian life. But there are so many potentials for there to be a completely different kind of war waged in the civilian sphere that don't look like war, but it's the opportunity for weaponization. I'm looking at, okay, how many of these applications are going to be therapeutic in a medical environment?
Those
and how many of them
use technologies, Indy? You're right on point. And I hate to interrupt you, but you're right on point. It's the medical innovations.
By the way, just for people, I'm putting the link out in the chat for Dr. Emily Rauscher, and there is
it's Elizabeth Rauscher.
Oh, Elizabeth. Oh, wait a minute. Then I got the wrong one. I won't put a. Thank you. I want to put the wrong one out. Thank you very much. Okay.
But what you're talking about are dual use technologies. So from a medical perspective, there's lots of benefits to understanding the unique resonant characteristics of the biological organism. There are resonant characteristics within resonant characteristics within resonance within resonance, and to be able to dial in very, very, very specifically and be able to modulate biological functions without having to use chemical-based medicines or necessarily even plant-based medicines, phenomenal. Absolutely right. Phenomenal. You're talking about quantum medicine. You're talking about Star Trek level medication, right? Like really future sci-fi stuff that we would look at and say, oh, wow, that's sci-fi. That's in a movie. It couldn't really happen. Well, it's happening. It's absolutely happening. And they're known as dual use technologies. So what can be used to provide radically advanced medical cures can also provide radically advanced weapons technology. And the civilian prosecution of a war that you were alluding to earlier, Indy, the best term I've heard, and it was really coined when it was discussing trying to understand and track everything that a human does, which is why you go to the credit-based system and no cash and everything is monitored and managed. It's really this idea of silent weapons for quiet wars. And the technology is good enough now where you don't necessarily need to prosecute a war with guns and bombs. You can do it with information.
That's right.
And information doesn't necessarily stay exclusively in the form of propaganda. What we would understand is things coming out in the form of news stories and commercials and social policy, right? The newer ways to do this with information is to transmit and receive information that is potentially formatted in the form of biologic resonant code.
Right.
Where you can transduce information, digital information from the internet can be transduced, which means changed into biologic signaling as it nears the body.
It's more direct. It's more efficient. It's a method of directly changing thought patterns, views, ideas, and memories, as opposed to having to try to convince somebody from the outside over and over again with propaganda. It's direct and very efficient.
If you go to Google Patents and search Elizabeth Rauscher, you'll see the few patents that she has. Even though she's done, I mean, she's worked at, I don't remember if it was Berkeley National Lab. She's worked at national laboratories for the United States for a long time.
It was Berkeley. I've got it up in front of me here.
Yeah. So she and a few others were really the pioneers of electromagnetic based medicine. And Alan Frey, F-R-E-Y or F-R-Y-E, he was the guy that developed the voice to skull technology, or he at least pioneered it. It was known as the Frey effect. And she mentions and speaks very highly of Dr. Frey, who was, I think, a generation before her. And like I said, I watched an interview with her, and then after reading the patents, some of the patents that she has, it's just absolutely amazing lady. Just an amazing lady.
She may have made just as many enemies as she made friends too, I'm thinking.
Because I would imagine dealing with these kinds of technologies. I mean, she comes outward and states that she's worked on, government projects that she's not allowed to talk about. She actually comes out and says that. So she's yeah. The short answer is yeah.
Right. I've got that Google patent page. I put that out there, and is that something that you've got on humaninternet.org as well?
I have not put her patents up there yet. I'm not entirely sure where I want to put them. I think they're going to go underneath the some electromedicine section.
Yeah, that's what I would be thinking. Yep. Mm-hmm.
But there are more electromedical patents that need to go with her patents, and I haven't finished sorting those. I will at some point, but they have.
You do a lot of work. You know that you do so much work behind the scenes. You are a research engine. Let me show you the
spreadsheet real quick.
Okay.
Google. It's Docs. There it is.
That's right, Ramred. The more on point you are, the more that you get attacked. That's right.
So this is I have this spreadsheet that I'm working on, and I'm going to scroll slow. So for those of you that want to go back and screenshot these things and look for yourself, I'm going through these things and categorizing them for what they are: electromagnetics, radar, nanotechnology, stimulators, sensors, different types of electronics, nervous system manipulation with magnetic fields, planar loops, which are coils. But there's 500 different entries in this spreadsheet here. And I'm going to speed up real fast just because I don't want to spend a whole lot of time on it. I mean, this goes down. There's over 300.
And look how much work you've done. Look how much research you've done.
There's I'm starting to categorize. And so emotion, biometrics, antennas, proximity sensors, radar, beamforming, ultrasound, ion cyclotron resonance. This is I haven't been able to spend the time on this that I want, but damn, this is really where it's at. This is where I see directed energy systems interacting with biologic life below the FCC regulations. Ion cyclotron resonance. This is where it's at. Whole bunch of white papers that I'm just randomly picking up to provide supporting documentation. Antennas and body. All of these are patents. Antennas and body communications. So I'm starting to group them, but this is really a consolidation of the thousands of tabs that I've picked up and slowly starting to clean up. Electromedicine. So going back to Miss Rauscher, right? All of these are electromedical based patents. Some are electromagnetic, some are ultrasound, some are software based, but most of them are electromagnetics. The other thing that I just found I would say within the last few months, is this idea of resonant acoustics, and this idea of being able to use electromagnetics to generate acoustic resonance in the body. And this is done by rapidly heating up and allowing to cool the tissues. So what the FCC requirements are is to not have a person exposed above a certain level of radiation over a 6-minute period or over a 30-minute period. That being said, that's a cumulative or an averaged amount of exposure. So if they can pulse radiation, electromagnetic radiation on a biological at the nanosecond scale or the millisecond scale, they could generate ultrasound in your organs or in your tissues without exceeding the average exposure rate of 6 minutes or 30 minutes at, I think it's 10 milliwatt per centimeter. That's the exposure level. So they can use less than 10 milliwatts for longer than 6 minutes or longer than 30 minutes. And this is based on whether or not you're the general public or if you're a worker that has to work around this stuff. Or what they can do in order to stay compliant with the average is they can have a peak transmission that over a 6-minute or a 30-minute period of time average is below 10 milliwatts, for example, 10 milliwatts per centimeter. So they can expose you to way more if it's for
very brief
a cumulative amount of time of 10 seconds where they have pulsed and phased energy at you in the millisecond scale, right?
Exactly.
So that's 1,000 pulses per second, potentially 1,000 pulses per second. And they can do the math. And over the course of 6 minutes or a half an hour, if they only pulsed you for a total of a minute, they could theoretically pulse way more than 10 milliwatts per centimeter squared into your body and still be in compliance with the FCC.
Yep. And they're figuring it out based on it's like milliwatt minutes, you know?
And it's all done with software and algorithms at this point. So this is where the cyber piece comes into play and why I think the heavy push to keep China, or to get China out of our networks, because we're putting up antenna systems that are going to enable some very, very interesting things like resonant acoustic effects of your organs or ion cyclotron resonance of your brain and your nervous system. I mean, it goes on and on and on. Cerebral programming. This section's crazy, where all of these things are related to. Most of them are either using ultrasound or putting electrodes on the head, upwards of like no more than some of the patents talk about no more than 4 different electrodes strategically placed on your head to do things like alter your memory or to put false memories in or to take memories out. Here's targeted steerable transcranial intervention to accelerate memory consolidation. This is a Darpa funded patent from, I think, all of these are HRL laboratory.
Now, what do they mean by memory consolidation?
Yeah.
What does that term mean?
What this means is that they're able to, when you're asleep, they can put a minimal amount of electrodes on your head and they generate electric fields and they can steer these electric fields around based on what direction you're applying the voltage. You have an anode and a cathode, and that basically in a DC circuit, there's a positive side and a negative side, and you can have 2 sets of them. Right. So you have four pads, if you will, strategically applied to the head. And then based on the amount of voltage the amount of current that is applied between the anode and the cathode, the positive and the negative, you can get the 2 sets of pads, the 4 in total. You can get the electric fields to interact and start steering in 3 dimensions what center or section of the brain you're influencing. And they can get into the hypothalamus and other deep center of the brain regions where dreams and memories are interacted with, and they can actually implant memories, and they can take stuff away, and they can reinforce learning. And so what they talk about here in some of these pads, or some of the examples that they use, is like for flight simulator training, where they put you through a flight simulator training, and then they record all of it. They put you an EEG system on, and it's either light based or electrode based, and they record your brain activity while you're going through the flight sim. Then when you go to sleep, they re-stimulate your brain while you're sleeping, and it's like going through X number of flight simulations while you're dreaming, so that when you get up the next day and you do it again, you're way more proficient than had you not had the stimulation while you were asleep. Isn't that amazing? And this is just what they're telling you they're doing, to make pilots more effective. I mean, so who knows what they're doing with mass deployment of headphones that have electrodes on them that are able to generate electric fields and interact with your nerves, and the antennas that are in the wireless earbuds that connect your Bluetooth to your phone. What those are doing with their near field electromagnetic generation, they can generate near field electromagnetic characteristics. 2.4 gigahertz wireless signal, one wavelength of that is roughly 12.5 centimeters. And if you were to calculate how far it is to the center of your brain, it's approximately 12 centimeters to the center of your brain. About 4 inches, right? Yeah, maybe less. So what they're building, or what they've built, and what they've deployed in the consumer space, the only link at this point that I don't think is publicly available is the software. Right. Being able to run the software over the internet to interact with the general population in the same ways that they interact with soldiers in controlled training environments. And that's where this stuff is developed. That's who it's developed for. But then it immediately translates. Yeah, the hardware piece is being done. Exactly right, brother. The hardware, you got it. Yep. So anyway, this is, at some point, a lot of these things are going to go on human internet. And when I get this spreadsheet, reorganized enough, I'm going to post the spreadsheet publicly, and just say, have your AIs, take this information and see what your AIs come up with, what's possible. Yep. Because it's crazy, and there's more. I mean, I've got a section on quantum. All of this stuff is quantum, either patents or papers. There's not a lot here, so I've consolidated this because this is the area that I don't really understand much of at all. I have a very, very high level conceptual understanding, but not close to what needs to be done. And then, satellite comms, and then there's a whole bunch of stuff in here to be sorted. I mean, it's just, and I'm not even done adding stuff to this. I still have hundreds of tabs open. And there are other whole areas. See what you just ran across right there, flipping a light switch in a cell, quantum dots used for targeted neural activation. That was back maybe 15 seconds ago, because that screen I saw it on was delayed. Yeah, right there. Yeah. This is one, we're concentrating on one kind of area right now. But then there are other arenas of research. There are whole different arenas. They have, they're at the level of DNA and DNA code and quantum information processing at the cellular level. That's right. We're not even talking about that right now. That was many episodes ago we got into that, and we will get back to it because the stuff continues to advance. But there are so many areas of very advanced research that it boggles the mind. This is where I think that the communication networks are going. I think what we're building, it's just my opinion, and this is why I've saved all this quantum stuff. I'm very interested in what they call free space quantum communications. There's a patent here that really had me going. Free space. I have never heard that term before. It's basically wireless quantum. So when you think of quantum communications, you think optics, you think something in a fiber optic cable, or
Yep.
right, or
Yes.
laser. And so free space quantum is using electromagnetics, whether it be laser or some other wavelength of light, all the way down to microwaves and millimeter waves. They have quantum communication with satellite networks down to terrestrial based networks using what they call free space quantum communication. And that's exactly what this patent talks about. There it is. I think this is it. And what it really talks about is being able to send encryption keys. This is not it. So that link didn't take. Anyway, this is a Verizon patent. There it is. That discusses transitioning or transferring quantum keys. It's not the one. This is the Department of the Army. This is not the patent I was actually thinking about. But still, nonetheless, it's a good thing to look at. Free space quantum communication process operative absent of the line of sight. So what they're talking about is being able to send communications through polarization variation. So what that means is that when you transmit electromagnetic energy and it passes through like a dirt in the sky, or it passes through trees, or it passes through moisture like clouds, it changes the characteristics of the electromagnetics, and that changes the polarization. It changes the amplitude, changes the polarization, it changes the speed, the time of flight,
Sure.
all of those things.
Yep.
And when you're dealing with quantum communication, it's a very big deal. It corrupts
It'll invalidate it. Yep.
Mm-hmm. So what they're talking about is entangled photon quantum communication protocols that are able to propagate through environmental scattering media such as air, smoke, fog, rain, and water. And it says here, while ultraviolet light photons are well suited as a carrier for quantum communication signals scattered in the air, it says it's appreciated that visible wavelengths have longer propagation paths in water to convey non-line of sight data. So think about Navy submarines, or that kind of stuff.
By the way, not to interrupt too much, but there are people who know a lot of stuff, and I've kind of been following along and learning a little bit, but who would maintain that there is actually no such thing as, the way that we understand it, quantum effects or quantum communication.
Yeah.
And that what it is that it's something that is being interpreted as a quantum effect or a quantum phenomenon by physicists, but that it's really something else. And that's a whole nother level that I am studying and haven't made it too far. But with the help of that individual who's out in the chat, I'm highly interested in it. But there are a lot of people who use the term quantum, and it's because it's whatever it might actually be, it seems to be exhibiting these effects that they're using as their explanation, much like any other science that's in a process of evolving, but it's not at a higher level of precision yet. So I'm just trying to recognize that other view out there.
So we had 20 minutes left. I don't know where you want to go.
I think we kind of reached a point that it might actually be good for a change to start to summarize a little bit. And I think we could talk a little bit about that, what the modern day, war, talking about war, right? We talk about war, we think of military, and we think of, tactical deployments of forces of various sorts. And we've already kind of covered how, changing, immobilizing the adversary can be done in a way that you can just make them blank right out. They're gonna crash their plane. There's other ways of doing things, and what we've thought of as war and battle have some of the same purposes. The purposes remain the same, but the methods and the character and the outward vision or the outward manifestation of what a war looks like, totally different. It's changing altogether, and in such a way that there may be people who might not even realize that war is being waged on them but it is, because they might be totally unaware of it. And so the character of war and battle is changing, and it's being fueled by the engine of advanced technology. And we might bat that around a little bit between us and the chat for the last few minutes that we have left, but it's a big deal. Things are changing. I mean, actually like dropping, bombs of C4 on a building. Yeah, you can still do that. And there'll be some of that done. But you know what? Where the real wars are going to be waged and where they are going to be won and lost is in a whole different environment now. It's rapidly changing. But maybe we covered it already. What do you think about that?
It's all information. And so we need to sort of, I think, redefine or expand our understanding of what information means. When we think of information, we typically think of sight or sound information. I'm getting information from typically my eyes or my ears, or from the other five senses, right? It's just information.
What constitutes losing a war is when you get bad information, or when information gets removed from your consciousness, you've lost a little battle, right?
Yeah, or when information is presented to you, or for all intents and purposes inserted.
Yep.
That causes you to change your trajectory, that causes you to change your perspective, to change your outcome, to change your actions.
Yep.
And that information, ultimately, if it moves over the internet, it's digital. So there's this rapidly approaching, it used to be a creeping effect, and now we're in a run, if not in a car, or an airplane, or potentially on a hypersonic missile, with this evolution, or this fusion of digital and biological.
So a weapon would be implantable information that alters your trajectory and causes you or me to do an operation which will ultimately be playing into the adversary's hand, even though we don't know it.
That's right. So it's no different than being maneuvered.
It's just like a battlefield. It's just different.
Exactly right.
Yep.
The battlefield is the human mind.
Right.
Human mind is the final frontier for all intents and purposes. And you can argue that it's not, but I'll submit to you, as far as we as the layman understand, it is. Because understanding and controlling the human mind means that you get access to, are able to manipulate, control, and steer consciousness. People's
will. Change their will, change what they do, maybe even get them to off themselves. Who knows?
If you're able to steer and control and dictate consciousness, that is a gateway at this point, 7+ billion different gateways into other dimensions.
Think of that. Just think.
So fusing the digital space with the human ultimately is after the consciousness, because the consciousness is expressed through the human, which allows us to interact in this dimension. But the consciousness is transcendent for all intents and purposes. If you believe there's a spirit, if you don't, then this conversation may not apply in your worldview. But if you believe there's a spirit, if you believe there is something that is separate from your 5 primal senses that ultimately is given to you upon conception, that is really what is being sought after.
Either way, the information that we present here can still be used for the benefit of people who can grasp it and utilize it. If one's worldview is one that's limited to just this terrestrial plane, okay, this is still helpful. If not, and if one believes that there is a higher, more ascendant spiritual form, our life essence of our conscious identity, whatever you want to call it, then this is still the battlefield that we're on, and it's battlefield of the mind. It's the battlefield of information and basically making people do things that they wouldn't otherwise do. And what what more could you want than to do it so silently, so quietly, so easily? It's much less messy than blowing up a whole countryside. And at the end of that, you haven't changed minds. In fact, it might even make the adversary even more opposed to you. This is high-powered warfare, potentially.
Yeah, it's very sophisticated, that's for sure. Very sophisticated.
You think that the battlefield is really in our own minds and in our own immediate space right around us.
It's always been that way.
And that some of the weapons, I'm just going to, this show is for entertainment purposes only. We're only here to amuse you. But that being said, if you think that one of the weapons that could be used against you is your own phone, wow.
Just because you can't see it doesn't mean it's not there.
Right.
70% of our perception of our existence is done through the eyes. 70% of your information uptake is through your eyes. So that is a tremendous strength, but it's also a tremendous weakness. To discount or disbelieve or to not consider something,
believe what you're seeing,
see it.
Right? Or believe what you're seeing, and it's just an image that's been put in front of you, or not see or sense what has been electromagnetically conveyed to you without even being aware that one's own thoughts or memories have been altered. I mean,
yeah,
that
electromagnetic
is so,
or acoustic. Acoustics are huge too. We'll do something on acoustics one day, Indy.
Yep.
There's all kinds of patents that.
Well, these are some really good thoughts to leave all of our participants with, and I just like to turning my attention over to what's going on out in the comments from the other half of this operation, which is out there. And we're talking about, phones could be, they could be. Hearts and minds, that's right. You know something? That participant out in the chat, that was actually the title for this episode, and I changed it. And you just said, what'd you say?
I said, I remember talking about that with you, yeah.
Yeah. You know something? There just might be some sort of a resonance going on there, Toy Maker, because that I had it was on the headline for the title of this show, and then I changed it to something a little more catchy. I said, well, yeah, hearts and minds, people could interpret that a lot of different ways, but now that you've participated in the discussion, you know that it is about hearts and minds. But I thought a catchy title that people would want to check out would be The Very Smart Smartphone, So anyway, very cool. I'm scrolling back here. We got a couple minutes left, and really have to appreciate the participation. We would have no purpose in doing this if nobody was interested. And this is highly relevant stuff. It is so huge. So anyway, on the bottom on the scroll at the bottom of the screen is the URL to TMC's webpage, and he works so hard at that. It is found at humaninternet.org. And I think TMC, maybe it's time to wrap it for the day.
Yeah, why not?
All right. Thanks for joining us, everybody. We'll be back next week. We're going to go further. Stay with us and do some reading of your own. Whatever, any aspect of this that interests you, it all helps to expand our consciousness and our awareness. So thanks so much. Have a great week, and we will talk to you again soon. Good night, everybody.